In this video, I will explore Microsoft, Microsoft Foundry security features. Microsoft Foundry offers several safety and security features that will help us to protect from AI models and AI agents, large LLM models and AI agents. There are features like security guardrails that we can apply to core models and agents consist of security controls. The controls define a risk to be detected, intervention points to scan for the risk, and the response action to take the model or agent when the risk is detected. Let's explore, let's try to understand a little bit more on what exactly uh, these controls do. So here the focus areas are risk to be detected, defining risk to be detected. So these are the risks. You can see different kind of risks that uh, guardrails can detect. There are several controls. Through those controls, they can detect, and then intervention points or something when to detect those uh, risks. Is it when the user providing the input, or is it when we are getting the input from the other tool, or is it when the output is going from this tool to other tool, or output is generated by this tool? These are the intervention points. The risk will be detected. Let's go. Let's uh, see this, explore this practically. So these are the guardrails. This is how you reach to the guardrails of in Foundry. And I'm selecting one guardrail and I will edit. You can create new one also. So this is how the guardrails screen is visible. So now first explore how to define a risk to be detected, where that will be that we can see, and also see intervention points to scan for the risk, and what is the response action this is taken um, when risk is detected. First, checking that the types of risks. So you can see there are different types of risk: jailbreak, indirect prompt injections, content safety, protected materials, sensitive data leakage, and task drift. And now I'm selecting jailbreak. And what is the intervention point for jailbreak? Is only user input. So jailbreak is basically if a user is providing wisely crafted prompts to mislead your model or agent. So the intervention point will be user input for the jailbreak. And the action, what action can be taken? Either it is a block or annotate. Annotate means monitor and log the information, but do not block. And so this is what we try to understand what exactly this paragraph is saying about. Then we'll go ahead and try to set some controls, and how do we make this control, how to set up this. I'll try to explore how to set up these controls. Now I have selected jailbreak, and intervention point is user input, and block is there. I'm selecting block. this time. I'm not doing annotate, selecting block. I have just clicked on add control. Now this control will be added to the guardrail. You can also try this break with annotate, and it will replace the previous control which we configured as block. I just wanted to show that, but yeah, now I'm selecting block. So now we have the jailbreak control with block action. Now let's explore indirect prompt injection. In the indirect prompt injection, you see user input also, intervention points are user input also, and tool response also. Tool response is something if there is one agent which is producing some document, some web page or something, and that is coming through this agent, there is a possibility that there are some misleading prompts in that document is also. That is the reason tool response is also here. So that means if any misleading command is there in any of the document which is produced by other tool, it should be detected. That should be one of the intervention point. By the way, indirect prompt in the sense prompt injection, the misleading commands will not be given directly in the prompt. They are given in some document, web page, PDF, any this kind of uh, any of these kind of documents. So the misleading prompts are inserted behind or in between the legitimate prompts, so that to trick the agent to read those misleading prompts and act on them. So here similarly, we can select both user input and tool response, and yeah, you can select block or annotate based on what you wanted to do, and add control. Now we have indirect prompt injection control also with block action and intervention points are user input and tool response. Now in the indirect prompt injection itself, we are also seeing something called spotlighting. Spotlighting is another defense mechanism uh, where it works hand with indirect prompt injection to protect from the indirect prompt injection attacks. So this is basically what happens. It will not block the prompt injection attempts or misleading prompts in the document or wherever, but it will, when document is being read, it will highlight those misleading commands. So the agent or your model will skip those instructions. And if you see here, we don't have a block action. It is only on. That means we are not blocking with this control. We are just switching this on, so it will highlight those misleading prompts which are coming from user input. Uh, user input. I'm just a little bit more. I'm just exploring and trying to understand a little bit more on spotlighting. Spotlighting, if you see the definition, spotlighting is a security and prompt engineering technique designed to protect LLMs from indirect prompt injection attacks. Why it is needed when AI agent reads outside data, it might process hidden commands meant to hijack its behavior. Because AI traditionally struggles to tell the difference between user requests and instructions embedded in the data itself, it risks executing dangerous commands, assuming they are the user information, though some misleading prompts are mentioned, it cannot differentiate between those misleading prompts and the benign prompts. So, how spotlighting works? Spotlighting physically alters and marks unstructured content before it reaches the model, essentially telling the AI that read and summarize this, but do not follow any commands written inside. So that is how AI models will skip the misleading prompt. There is a little bit more on delimiting the data marking and encoding that can be explored later. Now, so how do we, so the same thing was setting it is important, easy. Uh, and then we'll go to the next section, next risk, which is hate under content safety. So here we have two more intervention points, that is tool call and output. So hate is something, if either hate is something like the user prompt or by the response given by the agent or model may contain the words or phrases or which have hate related information. So here, as I was mentioning, there are two more options: tool call, tool response, and output. Let's try to understand these intervention points a little bit in detail. Tool call is outbound. That means when structured action, function name, or specific arguments the AI agent proposes to send to an external tool. So that means this tool is producing some information and sending it to another tool outbound. And tool response is something the data is coming from another tool and which is going to ingest it to your agent. So it has to detect all those, whether it is a user input, whether it is a tool call or bound data. The data is going to the other tools and agents and tool response. Their data is coming from other tool to uh, to this tool. So here we have block action, and you can also increase the severity levels, lower, medium, and highest. How do you want to, what scale you want to block those, and add the control similar to the previous controls that we have added, that I added. So similarly, we can select other content safety risk types and configure uh, the intervention points and action to be taken. All of them have a similar intervention points, same intervention points. All the content safety control, content safety risk types have similar intervention points, same intervention points. And in old version of Foundry, now we are in new Foundry, but in the old version of Foundry, we can also test the severity levels and risks before deploying, and just to understand how these guardrails or controls are working. So if you go to the previous old version under guardrails and controls, you see try it out option. Under that you can select. Let's say if you want to select the moderate text, select the moderate text. It displays some text in the text area. If you are selecting safe content, it will display some safe content, and then we can play with the thresholds under configuration filters: low, medium, high, for violence, self-harm, sexual, all these risk types, and play how these are working on blocking these risk types. Since now we selected safe content, the result is allowed. But if we select violent content with misspelled, or yeah, any other thing, it will give a it will take a desired action. So now here we see some violent date information with misspelled, but still it is blocked. So that way you can test different ways and understand. Now proceed further and understand about protected material risk type, where you have protected material for code and protected material for text, and then we have groundedness and other two risk types. Now let's select protected material, and protected material for text and code. We have four intervention points similar to the content safety, not, and then you have block and annotate and controls. So understanding the what protected material, text and code is important here. Protected material detection is safety feature in AI, Azure AI content safety designed to identify and block AI generated outputs that match known copyrighted or licensed content. So if your organization has copyrighted data, licensed content that is being produced by your agent through the direct output or tool response, as a tool response, it is going to the other agents or other models. It's this particular control will detect. And next, this is about text, and you will also have code. So sometimes your organization have some code. It is not always data. It's also sometimes your organization has a code, especially if a company is a software development. Uh, then so code also that could be intellectual property of your organization, that should also be protected. So then we'll see the next option, PI, personally identifiable information. In the personally identifiable information, you can select what are the kind of uh, user information that you want to protect: name protection, phone number, address, email protection, all those things. And you see intervention points are similar to previous risk types like content safety, and you have block and annotate options. So by the way, By the way, PII means personally identifiable informations. Privacy reasons, it is very important to protect personally identifiable information. It depends on what industry your organization is in. In some of the organizations, let's say if it is a financial institute or banking organization, then protecting credit card data and personal information like PAN is necessary, SSN is necessary. When it comes to a medical or healthcare environment or hospitals, PHI, protecting PHI information is important. So all this kind of, whether it is a PHI or any other um, PII, that should be protected. If your tool is dealing with those kind of data or agent is dealing with those kind of data, it is very essential to detect them and take necessary action, detect them at right intervention points and take necessary action. Now let's go and check other risk type in the what we have on the board. Yeah, next one is task adherence. Task adherence is something which will protect the task drift risk. Task drift is something is one kind of risk in AI security where your model slowly will derail from the actual task that is being assigned to. This is because of several reasons, like uh, like uh, when some real world conditions are changed, user habits are changed, or underlying models may evolve over the time. This will cause AI to stray away from its initially intended purpose or the original accuracy. So they will go away from the actual purpose and original accuracy. So this is called task drift. To protect from these risks, task adherence is the control that will help. Let us see how task adherence control works. Adherence system monitor an agent behavior in real time by evaluating the key intervention points. As we have already seen, user input, tool call, tool response, and tool outputs are the intervention points the uh, where the risks are detected. So in the user input intervention, at the user input intervention points, it scans the initial prompt that's sent to the agent. At the tool call intervention point, checks the action and data that agent proposes to send to an external tool. So it monitors when the data is proposes to send to an external tool, and whereas in the tool response, monitor the content returned from a tool to this agent, and output is something when final generated code completion generated before it reaches the user. Before it goes to user, it will monitor all this monitor the data at all these intervention points. And yeah, I have set all the risk types, all the controls for all the risk types. Now you can add the agent or model that you want to apply this guardrail to, and So all the guardrails that we have selected with the intervention points, risk types, and the action to be taken will be applied to the selected model and agent. So this is what using guardrails in Microsoft Foundry we can protect the models or agents from the known risks from the um, uh, known risk of AI security. And all these risks are basically mentioned in OWASP top 10 risks for LLM. Can go ahead and check that and and understand more about what are the types of risks or what are top 10 risks in related to AI agents and models.